More before we take a quick 5-minute break. Who wants to go next? Dan. Go, Dan.
So,
Sorry about
yeah, I don't have my starter project here today, but I built a small digital clock, and it had an alarm clock on it. It had an alarm built into it, so that was really helpful. I can't really talk in detail how much about it because I don't have it, but it was really helpful because it was one of the first things that I had to build with a lot of, it really got me into the mood for building everything else that I was building in BlueStamp, because I understood that it didn't just come as a kit and it didn't just come as a kit that you click two things together and it all worked. I had to understand how it worked in order for it to work at all, because I needed to know how to wire it. So that was very helpful for the rest of my project. So for my main project, I built a mini wind turbine. And I chose to build a mini wind turbine because I wanted to choose something that would be helpful to me later and something that was portable. So this was perfect. And the way that it works is that when the propeller spins in the wind, it spins the shaft that's attached to a magnet in here, and the magnet has poles on the face. And then the magnetic field causes a flux, and it induces a current through the wires, and that comes out as an AC current, which basically looks like a sine curve. I'll show you that in a second on the oscilloscope. And then today I was able to finish building the circuit, which is going to store that energy inside this capacitor. And the capacitor isn't very large right now, it can't store that much, but I plan on making a lot of improvements to this, so maybe I'll be able to charge more things if I can improve the efficiency. So some problems that I ran into. Primarily, I originally was using acrylic that Kyle cut, but the problem with that was whenever I dropped it, it would shatter into a million pieces. So I realized that I could use a 3D printer that Matt has to print whatever I needed. And that was also a really big step for me, because once I figured out that I could build whatever, like I really had a lot more freedom than I thought I had, I was able to make significant improvements, and I didn't have to spend so much time on the internet trying to find exactly what I needed. I was able to just figure it out myself. So that's how the 3D printer really helped me. I also, last week I was having a lot of trouble generating a lot of current because it wasn't spinning very well. And I realized that the ball bearings that I had, first of all, I wasn't using them correctly because I need to have one track has to be attached to something that's stable, and the other track has to be attached to something I want to rotate. But the whole thing was just attached to what I wanted to rotate, so it wasn't really helping me. But now I have lightweight ball bearings that spin much easier, so that will be able to help me a lot more later when I epoxy it in. And also, I plan on getting a cover, so it'll be able to be protected outside, and it will have a fin attached to the cover, so that it will be able to turn into the wind and generate more electricity, because it wouldn't be very helpful if it only face covers the wind on rare occasions. So now I'll show you how it works. Sorry about this. I was really only able to finish the circuit at the last minute, so I don't have a very good system for hooking it up. But it works nonetheless, so. Sorry.
This is real engineering, by the way. You see the glamorous side. Yes. Oh, this is the files we didn't show you tonight.
Careful.
So, one of the main benefits of the 3D cover, of 3D printing a cover, is that I'll be able to have a hole on the bottom that will go through a shaft, and I'll be able to collect all the wires through, and it's going to be much more organized, nothing exposed to the wind, except for the propeller, obviously. Oh yeah, another big problem. Oh, I already talked about it.
Yeah.
There's the sine curve that's showing. So there's a sine curve that's showing that's generating alternating currents because when the poles oscillate, it'll cause one end to be the negative pole and the other end to be the positive pole. But a second later, it'll be the opposite. So that's why I built this bridge rectifier inside that turns the negative. When the current is negative, it makes it positive because the diodes are going to force the current to go in only one direction. So all of the negative current becomes positive, and then I'm going to smoothen it out later on, and it'll become more of a DC current. So I'll be able to use it for other things like powering, maybe USB if I could make it efficient enough. And yeah, it's really great because now that I realized I could 3D print it, the possibilities are endless. So I could really just keep on improving it forever. Yeah. Any questions?
How did you make the blades?
The blades, I ordered them, but I realized afterwards, Matt pointed out that I could 3D print them, but I don't know that much about aerodynamics. So I understand now that the sharp end of the blade is going to be, right, that's one of the problems I need to work on. The sharp end of the blade is going to be, is going to rotate into the winds, and that's going to force the whole thing to spin because of the curve. Matt taught me more about aerodynamics so I could design a good cover. But yeah, so I could theoretically 3D print a propeller now, maybe even a bigger one, to catch more wind. But yeah.
What does it mean to 3D print a propeller?
So to 3D print a propeller,
Ken, did you watch the talk? You might want my topic.
Okay. So the way a 3D printer works is that it kind of looks like a sewing machine. I realized this weekend. But at the top, it has a little nozzle that could print soft material for like, for instance, plastic, and you give it a 3D model, and it splits up into small layers, and then it builds layer after layer after layer. So it comes out looking like this, but really it's just split up into thousands of really small layers, and printers are becoming more and more precise. But for my project, this is really all that I needed, and so the way printing a propeller would work would be pretty simple. I could either design one on my computer using SketchUp, or I could download a model of it, and then I just send it straight to the printer, and the printer prints it in a few hours. Yeah. Any other questions? Thank you.